we're going to talk about the law of sines in the case that is ambiguous. The ambiguous case, you might be wondering, what does the word ambiguous mean? And, you know, today we can go ahead and look it up online. I actually was home this past weekend, and I noticed on my bookshelf in my bedroom, which my parents still haven't cleaned out. I guess I should be the one to clean it out. Anyway, I noticed on my bookshelf I had this old source dictionary that I used to use because I couldn't look it up online. I mean, I could have, but then you have to log on to the internet. And okay, I'm getting off on a tangent. That just made me sound really old, by the way. What does the word ambiguous mean? If you look it up online, you'll see that it basically says that ambiguous means that it has several possible meanings or interpretations. So in terms of math, that just means that we could have potentially one, two, or no solutions to the triangle, specifically talking about what we're doing now. Side-side angle is the ambiguous case. Here's the reason why, which, by the way, this is in the book. This is like the book definition, which never memorize book definitions of things. Make sure you understand them. You know, this is only true for an acute triangle, just so you guys know. But here's what we mean. So when might we not have a triangle? Well, anytime that A is less than H, the hypotenuse. Sorry, the height, not the hypotenuse. We could potentially have one solution where A is equal to H. We could potentially have two solutions, which this is what's going to make the most sense. So potentially I find a side length, but that same side length could form two triangles, right? And then another case for having one triangle, but not necessarily right, okay? So again, I wouldn't memorize this, but this is just kind of having you guys understand why this is the ambiguous case, why we might potentially have one, two, or no solutions. If I use the law of sines, I get a side length, but it's possible that it could, or sorry, angle measure too. It's possible that we could have one, two, or no solutions. So, what if the angle A is obtuse? What are the possible outcomes and restrictions on those outcomes? Have you guys respond to that? And then let's move on. Okay, so we are going to solve the following triangles now. So you notice that we are given A, small a, which is the side length, and B, and we want to find the rest, which would be angle B, angle C, and then side length C. Now, I want to reiterate something here, is that when we have problems like these, there's really only one option of what you can solve for first. Okay, think about it. Law of sines. I'm going to have to use sine of A over A, sine of B over B. So really, angle B is the first thing I have to solve for in this case. You know, if you do get the no solution scenario, obviously you're going to figure that out right away, which is going to have to do with the domain of inverse sine. Okay, because we know that the domain is -1 to 1. So if it's not in that domain, then you'll get no solution. And again, that'll be obvious. If you do get one solution as your answer, you should assume that there's two solutions until you figure out that maybe the second one doesn't work, okay? So, why don't we start with the first one, and then I'll have you try the second and third one on your own. Okay, so to start, what I'd like you to do on your own is find the measure of angle B, like we just talked about. Okay, so go ahead, put me on pause, and then we'll talk about how to find the rest. We found out that angle B is 46.124 degrees, okay, which after that we just still need to find the length of C and the measure of angle C, which we'll talk about. However, like I was explaining before, we want to see, is it possible for angle B to, you know, be something else with these two side lengths? That would be the case where it's two solutions. So what we're going to do is we're going to see, well, and I'm just going to use the notation B prime. We're going to find B prime, which is always the supplement of the first angle. So if I did 180 minus 46.124 that tells me that B prime, my potential second solution is 133.876 degrees. However, just because I'm able to find a supplement does not tell us if we have a second solution. This doesn't tell me that a second solution exists. We actually have to find the third angle. Okay? So now we have to see, well, does C prime exist? Which, if I do that, I'm going to do 180 minus B prime, of course. And what's the other angle in this triangle? Remember, it's A, right? It's my given angle, so minus 17. And I get 29.124 degrees. Okay, so this confirms right here that a second solution exists. Now let's say, for example, that I had gotten a negative angle measure here. That would be my indicator that a second solution doesn't exist. So from there, I'm just going to continue to find my last thing, which is C. Here I need to figure out what is angle C, not C prime, and then C as well. Okay? So let's have you guys complete these on your own. I should probably make this a little C prime. All right, go ahead, put me on pause. So I found the measure of angle C by doing 180 minus angle B and angle A. So I got that angle C is 116.876 degrees. To find side length C, this is where I use that law of sines again, and I found that C is 17.695. That's a length. Remember, because this is an ambiguous case, we had to check if there was a second solution, which there was. So B prime is 133.876 degrees. We found that together. To find C prime, I'm going to do 180 minus both of them, which is B prime and A. And to find C prime, again, using my law of sines, but using these values of the second triangle, I got that C prime is 9.655. Okay? So what I'd like you to do next is try these two examples. Okay? Just as a hint, they are the other two cases where you might get no solution or one solution. This was our example for getting two solutions, which it'll be really obvious to you right away why that is. So go ahead, put me on pause, do both of them, and then we'll check both. Let's start with that second example. So remember we talked about there's really only thing we can solve for first, which in this case is angle B. I do that, and then I get that sine, I really should have the word sine. The sine of B, good notation. The sine of B equals 1.078. So if I took the inverse of both sides, remember, you're going to get an error on your calculator. Why? Because 1.078 is not in the domain of inverse sine. So this is that example where it is no solution. Okay? So let's check our other example here, the third one. So again, I solve for angle B first, and then right away I want to see, well, do I have a second solution that could potentially exist? So if I find out what B prime is, my potential other angle, I get that it's 159.911 degrees. But then if I look for C prime, and I do 180 minus the other two angles, which are B prime and A, the original A, we know that that's not going to work. So this is an example where we have just one solution, which I used my same method as before to find the rest. Okay, so the ambiguous case is the case where you have side-side angle, right? That's what's given to us. Side-side angle, okay? We know that ambiguous means we could have one solution, no solution, or two solutions. To check if we do have two solutions, we want to make sure that the angles of the triangle would exist, right? We want to make sure that they are all positive values. That would add up to 180.